In this lesson, we will rewrite fractions and show equivalents. So example 1, it has 1/2 equals how many eighths? We know to make or to generate equivalent fractions, we can multiply or divide. So 2 times what is 8? 2 times 4 is 8. If you don't know that, you can also divide if they're really large numbers and you have a calculator. But these are all going to be pretty simple numbers. So 2 times 4 is 8. 1, which is the numerator, times 4 is 4. So 1/2 equals 4/8. Let's show this pictorially. 1/2 equals 4/8. So 1/2, we need 2 pieces. We need 2 equal pieces. That's still a little off. One more. 2 equal pieces. That's a little better. And we need to shade in one of them. This one we need 8 equal pieces. 2 equal pieces. 4 equal pieces. 8 equal pieces. And we need to shade in 4. 1, 2, 3, 4. So we can see that 1/2 is equivalent to a 4/8. A statement is that 1/2 and 4/8 are equivalent. They just look different. So example number 2. 6/9 is how many thirds? In this one, we're not actually, we're making our denominator smaller. So one way you can do that is by dividing. So 9 divided by 3. 6 divided by 3. Remember, we have to divide both the denominator and the numerator by the same number, is 2. So I'm going to attempt to make this into equal holes, or like make the holes the same distance, or like length, we'll say. So we need to prove that 6/9 is equivalent to 2/3. What I like to do is I like to create the smaller one first, because it usually is a guide. I can use it as a guide to make the larger denominator one. So we'll start off with 2/3, because the 3 is the smaller denominator. Let's put this into 3 pieces. 1, I can do a little better. So 2/3. Now I like to use these right here. See how I made thirds? And this is kind of like a little, like, I don't want to call it a cheat, but it kind of helps, a little trick. So remember how we divided by 3? So what I have to do is turn each of these into 3 pieces. 3 pieces, 3 pieces, 3 pieces, because 3 times 3 is 9. So 6/9, 3, 4, 5, 6, 6, and is equal to 2/3. So 6/9 and 2/3 are equivalent. They just look different. We have 2 more. So 2 wholes is how many thirds? In this situation, it's useful if we represent 2 wholes as in 2 wholes. That way we know that, well, we can do the process the same way. So 1 times 3 is 3. 2 times 3 is 6. So 2 wholes should be equivalent to 6/3. So remember, I'm going to need 2 wholes. So I'm going to, I guess, I want to make my holes longer but a little narrower. 2 holes. The hole should be equivalent to 6/3. So since I know they're going to be equivalent, I am going to start off with the 2 holes. 2 holes. And I need 6/3. Remember, each whole, each of these wholes is 3/3. Because 3/3, 3 out of 3 is a whole, right? So here are 3/3. It actually might be easier if I start off like this. I created a whole. I can draw 3/3 at a time. But I need 3 more, so I'm going to draw another hole. And another 3/3. And I get 6/3. So 2 holes is equal to 6/3. Not too difficult. Let's do one more, because I know you can do the statement, right? So in this one, we are dividing, once again, our numerator is 8. We can divide it by 4 and get 2, and 12 divided by 4 is 3. So let's prove that 12/8 is equivalent to 3/2. So we know that we are larger than a whole. See that the numerator is larger than the denominator, so we have greater than a whole. But if I want to draw eighths, I'm going to draw a whole, which should be 8/8. So that's half, that's fourths, that's eighths. So that is, I can shade in 8 of them, but I'm going to need more of them. So I'll do it again. All right, to draw 8 at a time, or 8 slots, we'll say. And I need to shade in 4 of them. 1, 2, 3, 4, because 8 and 4 give me 12/8. Now I need to draw 3/2. This should be not too bad, right? 3/2. So I can draw 2 halves at a time. Remember, because 2 halves is a whole. So I can draw a whole and split it up into 2 halves. But that's not enough. I need another one to get to 3. So I'm going to draw another whole, and I need half of that. One of those halves. So I have 1, 2, 3 halves. And you can see that this 12/8 is equivalent to this 3 halves. They are just written differently. Because they don't really, like, the fractions themselves look different, but they are actually equivalent. And we can show that using these pictures. Thank you.